In this last video for Chapter 9, we're going to go through some hypothesis tests for means. And once again, just like in all of our problems, we're going to rely upon the t-distribution because the population standard deviation sigma is unknown. As well, we're not going to meet the central limit theorem. We're not going to have a large enough sample size. So we'll use the t-distribution. First example 1 says a random sample of 10 independent healthy people showed the following body temperatures in degrees Fahrenheit. Test the hypothesis that the population mean is not 98.6 degrees and use a significance level of 0.05. We're going to use technology exclusively for the calculations of our hypothesis test. You can do that by going to stat test number 2, the t-test. It's a hypothesis test using the t-distribution. So here are the temperatures of our 10 independent healthy people. First off, we're going to state our null and alternative hypotheses, our HO and our HA. This time, we're going to use mu equals instead of p equals for our null hypothesis. We're now talking about means and not proportions or percentages. So our baseline is that the average body temperature is 98.6. The alternative that we're testing as the mean is not 98.6. So there's a mu still, there's a 98.6, but it doesn't specify that it's greater than or less than, so I'll use the not equal to symbol. I want to see, well, what does this data show us? So to find the test statistic, this is going to be our t and our p-value. We're going to use our calculator, just as it said. We're going to go to stat test, number 2, the t-test. And just like we saw with our confidence intervals, you have two choices to begin with for your input, either the raw data or the statistics. In this case, once again, we have the raw data. We don't have the sample mean and sample standard deviation, so we want to have data selected, and we want to put that data into L1. So that's stat and edit, and we'll just enter these values in. Now that all these values are in, I'll go to stat test number 2. So my input is my data, it's already in there. My mu sub O, that's the mu from HO, that was 98.6. My data is in L1, the frequency should always be 1, and I need that not equal to symbol selected because that's the symbol in my alternative. If I go down to calculate, my t, or my t-score, is negative 0.52 if I round that to 2 places. I'll treat this t sort of like a z-score, so I'll round it to 2 places typically. And my p-value would be 0.6173. By the way, the sample mean is 98.47 degrees, so it's just below 98.6 degrees. But it's not significantly below 98.6. This would round to be 98.5, so that's not very surprising because samples are going to vary. Now to answer the final question with this scenario before we adjust it slightly, should you reject the null hypothesis? Well, that goes back to my p-value and my significance level. In this case, the p-value is greater than that significance level. 0.6173 is greater than the given 0.05. When the p-value is greater than alpha, just like we saw back in chapter 8, we do not reject HO. You can say you do not reject or you fail to reject HO. There's not enough evidence to reject this, Therefore, we don't think the temperature is something other than 98.6. And this is a pretty small sample size. We only have 10 data pieces. So part D addresses that. If the same sample mean and sample standard deviation came from a sample size of 50, what would your test statistic and p-value be? And would this change your decision about the null hypothesis? So I need to recalculate my test statistic and my p-value. I do that by going to stat test number 2, the t-test. And this time I don't have the raw data on all 50 people, but I do have the statistics. If you go over to stats and hit enter, it will automatically copy in that sample mean and sample standard deviation. Mu sub O is still 98.6. All I have to do is change that sample size from 10 to 50. When I calculate this, I get a new t. It's negative 1.15. And a new p-value, which is 0.2529. Still, my p-value is greater than my significance level. 0.2529 is greater than 0.05. We're talking 25% compared to 5%, so it's still the same decision about the null. Do not reject HO.